This video is going to teach you how to produce the tangent parent function, and we will also be looking at the other three reciprocal functions. If you take note of this particular part of the video, I did not use the scale that Delta Math was going to use because I realized it was getting kind of messy for the students, so I'm using just a pre-made where it's typed, so hopefully it's easier for you to read, and we're going to get going. All right, so we've already been working on sine and cosine, and at this point I hope you realize there are infinitely many points across any kind of function or graph that you're doing. We're focusing on certain values, right? The parent values. So for this one, just as a reminder, you're doing theta and then you're doing tangent theta, or you can say x and y, but I just want to make sure that you realize it's the angle measure that's going into the function. We're going to be using the following. So this is when you have to really keep track of. So we're going to start at 0 with the table, even though we're going to go backwards. So we're going to go negative pi over 4. These values give us a nice clean graph, which is why I'm using these points. And then pi over 2. And then the symmetry we're going to use here, which is going to make things easier for everybody. And remember, I'm not calculating every single point. We can get the graph pretty easily from this. I had to go in more detail with sine and cosine because I need you to realize that we're using all the values around the unit circle. But we'll just use these for tangent. All right, so if you recall, tangent has more than one definition you can use. So tangent of theta is equivalent to sine theta over cosine theta. So you could use this to use it straight off the unit circle. But what I'll say is, what if sine is 1/2 and cosine is the square root of 3 over 2? Then you now have these complex fractions that you have to deal with rationalizing. And yes, we're going to have to deal with rationalizing, but you can see that gets a little difficult. So what I like to do, and I don't care how you do it, but I think, in my opinion, it's faster to do it off the 30, 60, 90 triangle and then use the all students take calculus. Now, the way I'm doing is a little dangerous because students sometimes miss the signs. Okay, the all students take calculus. That's the only thing that I would say makes this one a little bit difficult. So I'm going to go ahead and draw my triangles outside of the unit circle that you know so well at this point. And if you don't, you need to have them written down somewhere, like at all times. They really are the foundation of all of this trigonometry that you're looking at. Or just right triangles are the foundation, right? Because we have infinitely many angles even though we haven't looked at them. All right, so here's the first thing I'm going to do. I'm going to calculate tangent of 0. So tangent of 0 is right here. So I'm going to use the sine cosine. So it's 1, 0 because why? It's a quadrant angle. And the ratio of that, the ratio is sine, which is 0 over 1. Cosine's 1, so that value is 0. So I'm going to come over to my nice, pretty clean graph, and I'm going to put a value at 0. Now I'm going to go in the positive direction, just because I think our minds work better with the positive direction. This should be 0 in here. Sorry about that. Tangent 0. Theta's fine too, but I'm trying to plug in the values for you where you're used to looking at it. Okay, pi over 4. Now pi over 4 is the 45 degree triangle. So if I use opposite, so instead of using the quadrant angle, I'm using an actual triangle in the unit circle. I'm going to bring that triangle out because instead of doing sine over cosine, which could get, right, like I showed you at the beginning of the video, if you use the triangle and use that tangent is the same thing as opposite over adjacent, then it just becomes a lot easier. So 1 over 1. Now, if you did it using the unit circle and stacking, you're going to get the same thing. Okay, so I'm going to come over to my graph and I'm going to graph that point. So tangent pi over 4 is 1. Now it looks like that we would just do a straight line here. That's not the graph. Remember, we have pi over 6 and pi over 3 in this portion of the graph. So we are going to get a curve. So just keep that in mind. Okay, the next one we're doing is tangent pi over 2. And that again is a quadrant angle. So we're looking at pi over 2, and the point there is 0, -1. So that's cool. And then we're going to do sine over cosine. Now here's the thing, it's undefined. So that means that at pi over 2, we have an asymptote. So it's a boundary line. It's a boundary line. Okay, so that's the beginning of the graph. So I'm going to extend using the end behavior from the asymptote to get really close without crossing it. Now I'm going to go in the other direction and do negative pi over 4 and negative pi over 2. Get myself some nice room here. Alrighty. So I'm going to do negative pi over 4 now. So tangent of negative pi over 4 is the following. We're now going in the opposite direction. And I'm saying opposite because remember, opposite is not reciprocal. Opposite is really a sign value. So I'm going in the opposite direction, and I'm going to go to 45 degrees here because that's pi over 4. So I know, again, I'm using that triangle, so I just have to watch my signs. That's the thing you have to know. We're in the 4th quadrant. So what's the only thing positive in the 4th quadrant? Are cosine and secant, right, the reciprocal. So I'm going to calculate that. So 45, so we have opposite over adjacent, so that's 1. But we're in the 4th quadrant, so that means it has to be negative. That's really important you know the signs or you're going to get a crazy looking graph. So we can now see the graph is decreasing. So we're going to estimate where that graph in the curve is. And then I wonder at this point if you know what's going to happen at negative pi over 2. So let's go ahead and calculate that. So tangent of negative pi over 2. You got to be careful where you are on the unit circle. Because remember, we're now going in the negative direction. So negative pi over 2 would be down here at 270 degrees because we're going in the negative direction. Which means we're, again, at a quadrant angle. So the quadrant angle produces the point 0, -1. So we can believe the signs. That's -1. Okay, so if we go sine, so we're going to use sine over cosine. So now you can see it's undefined. And we get another asymptote, which I'm sure you already knew at this point. And just as a reminder, what kind of function is this? Is this even or odd? Think in your head, is this an even or odd function? So going back to previous material we looked at, this is an odd function. Why? Because we have symmetry through the origin. Remember, we have 2 reflections. We have one going over the y-axis, and then we have another one going over the x-axis. So that's just a side note that you need to keep in mind. We're also going to be looking at all the characteristics like increasing, decreasing, all those fun things. We're just trying to get the basic graphs in right now. Graph number 4, cosecant. So if you notice in this setup, I have sine in the table this time. Because recall, what is one way to express cosecant? It's the same thing as saying is equal to 1 over sine theta. Remember, it's just the reciprocal. So if I figure out sine, then I can just go ahead and flip that upside down, and I'll get the other graph. So if you don't remember how to find the sine values, I'm just going over it real fast again. So I'm using my parent given angles, which are the x's, and then I'm going to remember that the y values are all sine. So I'm going to enter those into my table. These are all quadrant angles again. And then this is 0, -1. And then we're back up to 2 pi because we've gone all the way around the circle, so we're back at 0. All right, so then we're going to calculate the values for our actual graph, which is cosecant. So we're going to make another part of the table here. So this is cosecant theta. And you could use the special triangles if you wanted to. So there's nothing wrong with that. But this, I think, is a bit of a shortcut if you understand the relationship. And then the graph also becomes way easier, which is really, really nice. And this should be 3 pi over 2, and then this is cosecant of 2 pi. Alrighty, well, if we're going to flip the fraction around, remember there's a 1 underneath each one of these whole numbers. And so I'm going to go ahead and do that. So this is 1 over 0. This one's undefined. And then you just go and do the rest of them. So this one is 1 over 1. And yes, you should be able to tell me that it's reciprocal. I know it comes out the same as 1, and that's fine. But just remember what you're talking about. This is undefined. This one is, let's see, oh, it should be 1 underneath, not -1. So this one's -1, which makes sense. So this would be 1 over -1. And then finally we get to cosecant of 2 pi, which again is -1 over 0. So it's undefined. So what I want you to notice is this time you have 1, 2, 3 asymptotes. Next, what I'm going to do is graph sine. And I know that's not what our end goal is, but we're going to use the sine graph just like we did with the table. So I'll just go through, plus it's a good review for you. And then this is 1. We're back at 0, -1, and then finally back at 0. And I think I got to move my point just over a little bit. Let's see here. Okay, so I'm going to just blow that up so you guys can see where the points are. All right, so that's the sine graph. And if you've noticed, I haven't connected the points for a reason. As I stated before, this is not my end goal. I'm going to use the structure of sine, so it's really not here. It's just kind of a guide for what we're going to do. Okay, so now I'm going to take all of my information I have from cosecant. And remember, I have asymptotes at 0. You got to put them in the graph too. They're part of the graph. That way you understand where the behaviors and boundary lines are. And then you've got another one at pi. And you've got one more at pi over 2. So we're only looking at the positive part. And we're also only graphing one period. I want to make sure that's clear. Remember, this graph can go infinitely many angles, either negative or positive. So just keep that in mind. All right, so now we're going to graph the other values. So here's 1, and here's -1. Okay, so the asymptotes and the purple dots are what I have for cosecant. I'm going to let you guys do a shortcut because we're on distance learning. We would calculate this point here and this point, but because we're distance learning, I'm letting you know that you can use the asymptotes to get the rest of the graph here. And I'm going to be okay with that just because of the circumstances. And so what happens is the actual graph for cosecant is really the purple and the asymptotes. So you have 2 of these little U shapes Do not say it's a parabola, because it's not a parabola. And that's what your final graph would look like for one period. Okay, we're moving on to cosine, but I think probably for cosine you will understand it, so I'm just going to work it out with no explanation. Okay, the next one is cotangent. And unfortunately, we cannot use tangent, the graph tangent, in order to get the cotangent. So that's kind of sad. But we're still going to use the relationships that you've already learned. So cotangent is the reciprocal of tangent theta. And then in terms of your x and y, or just your definitions, it's hypotenuse over adjacent. Okay, so I've got to fix this. So remember, the parent values are the ones that help us get the graph easily. And I actually need to fix this because I have this one incorrect. And then we go up to pi. So I need to fix this one with the 2. Okay, we have it right now. So the period for this one, the period is 1 pi. Okay, so it's only going to be this portion of the graph to get the period, but it's still 5 values just like you've been working on. Another thing I want to point out is this graph starts at 0. If you recall the tangent graph starts at negative pi over 2. Remember, these are the critical points that get us that nice clean graph. So keep that in mind. That's something you're going to have to memorize or be aware of. And last but not least, remember the reference angles here. So this is one of those quadrant angles, and then we have 45 this time, which if you look at your unit circle or quadrant 1, because you know that so well, you'll see that if you go tangent and use the sine over cosine definition, and I'll write it out so you know what it is. This is going to be stacked where it's exactly the same. So I know I'm doing tangent right now, and this is the cotangent, but I'm just illustrating. So this would be something over the exact same something, which is 1, or you can use the unit reference angle here of 45, 45, and I meant reference triangle, where you have, for tangent, it would be opposite over adjacent, which still gets you 1. Okay, so either one of those methods are going to work for you, and the quadrant angles. Okay, so I'm going to go ahead and do that now without any sound, and you will complete your notes.